our Unit 5, Day 5, we're going to talk about two things that we've already talked about earlier this year. One of them is called an altitude, and one of them is called a median. So by definition, we've already talked about how if BD is the altitude in this first picture, that it's going to be perpendicular to the opposite side. So this right here would be our altitude. And if we were given that BD is the altitude to triangle ABC, our next step, according to the reason, is that we would say that BD is perpendicular to AC. So using this reason, we go in and we say that because we know we have an altitude, we know that those segments are perpendicular. And then we know, based on what we've been doing for this whole unit, that we would take that and go in then and start talking about our right angles. So what I need you to know is that when you have an altitude, you convert that into perpendicular lines using the reason that the altitude of a triangle is perpendicular to the opposite side. In the second picture, we have another line segment drawn in the triangle, but this one is a median. So what's going to happen is you're going to be given some information that you have a segment called BD that's the median to triangle CBA. And based on the definition that's given, what that's going to be telling you is that your median is defining a midpoint. So you're going to know then, because of your median, that D is the midpoint of CA, that opposite side. And then, of course, we know that once we have a midpoint, we usually have two congruent segments. So my goal is to make sure that you know that when you have a median, you go on and say that your median creates that midpoint. So if we take a look at a couple of the example questions down below, we're going to be given the information that we have a median for one and an altitude for the other. The interesting thing about these two questions is that there is no picture drawn for us, so we are expected to draw our picture on our own. So I'm going to use this information that's right here to draw my picture. So I have a triangle called ABC, and they're telling me that I want to draw in a median. So I'm going to try to make sure that when I draw my median in, that it looks like it's sort of landing at the midpoint. Now, if my triangle is called ABC, I have to take into consideration that this point A for the median is part of the triangle and the median, so I want it to be up here. This vertex is the only one that's part of both. B and C don't matter. Point D is the other edge endpoint of that median. So in my proof, I would put that AD is the median to triangle ABC, and I would also put in that other given that AB is congruent to AC. And then, like I said, the real reason that we're here is so that we can talk about what that median does. So when you see this line that's talking here about the median, you want to take that and say, okay, what does the median do? Well, it tells me that I have a midpoint. So I'm going to put in there that that point, D, is the midpoint of the segment called BC. Remember, we've talked before about how you can't name a midpoint unless you tell what it's the midpoint of. And this is because median of a triangle intersects the opposite side at the midpoint. And then, of course, we would continue on, and we would say, oh, we have a midpoint? Okay, well, then we know that these two are congruent to each other, these two segments. So I can put in here that BD is congruent to DC, midpoint divides segment into two congruent segments. And we've done that reason a lot, and you know that we would classify that with an S as it being a set of sides. And then as I continue on, I go back to the given. I've got this given that's right here, that these two sides are congruent. I say that's great, that's a set sides. And then I'm sure most of you are actually even ahead of me now. I also have reflexive in the middle. It's a shared side, so AD is congruent to AD. I'm going to mark that as a side. So in number 4, reflexive. And then as soon as I get to that point, I realize I've gathered up the 3 pieces of information that I need, and I can finish this proof up by simply saying that my triangles are congruent. So triangle ABD, congruent to triangle ACD, side, side, side in one triangle, congruent to side, side, side in the other triangle. Again, this is just a simple example of how to use the median definition in a proof, but it's also important because if you mess that up, it may affect where you're going with your proofs. So it's a vocabulary word, but it's also a process of how you write this in your proof. Now in question 2, same kind of idea here, but in question 2, instead of having a median, we have an altitude. Again, there's no picture drawn. So I want to draw a triangle that's going to be called ABC. In this case, C is the point that's part of the altitude and part of the triangle. So if I'm drawing in my altitude, I want C to go here, R is the other end point, and of course it doesn't matter where A and T go. I'm going to put the given into my proof. Triangle CAT has altitude CR given, and angle ACR congruent to angle TCR. So those are my 2 givens. I'm going to pick to work with this altitude first. So in this proof, I see that I have this altitude. As soon as I know that I have an altitude, I'm going to say altitude of triangle is perpendicular to the opposite side. And I'm going to indicate who that altitude CR is perpendicular to, which in this case, when CR comes down and hits the opposite side, it's perpendicular to AT. And then from there, I'm going to continue on, use perpendiculars like I would have used them all along. I'm going to label the fact that I have 2 right angles in here, so angle CRA is a right angle, and angle CRT is a right angle. Perpendiculars form right angles. And then, of course, the number 4, with the right angles, we have to go one step further and actually say that they are congruent to each other. All right angles congruent. And then from there, I'm going to mark this given in my picture, ACR congruent to TCR. Gives me a set of angles that are congruent. Remember, the right angles were a set of angles that were congruent. And I'm looking for one other piece of information, which I'm sure most of you right now see, that we have reflexive through the middle. So I'm going to say CR is congruent to CR. Number 5, reflexive. At this point, you guys have gotten good at finding that reflexive, also finding vertical angles. That gives me a side. So now when all is said and done and I go back and take a look at everything I've accumulated, I've got an angle here, a side here. That means I'm looking to see if it's angle, side, or angle, side, angle. And in this case, we're going to pick this choice simply because the side that we have in our picture, not in our proof, in our picture is between the 2 angles. So I can say now that triangle CAR is congruent to triangle CTR. My reason, angle, side, angle in one triangle, congruent to angle, side, angle in the other triangle. So on your homework tonight, you are going to be working on proofs that involve altitudes and medians, proving triangles congruent. So everything we've done in this unit so far will definitely come into play. And then we're just going to add this one extra piece on. So you've got a lot of foundation. We just keep adding more pieces on to add to the things that you can do inside of a proof.